Welcome everyone, my name is Richard Schneeman, or Schneems on the internet. So a fun fact about me, I am literally married to Ruby. So I'm not allowed to see other programming languages. Which is also interesting because my wife recently got a job as a Python programmer. So I come from the great state of Texas, the great nation of Texas, Austin. And just a little bit about my background. I'm actually not a programmer. I'm not a classically trained programmer. I am actually a mechanical engineer from Georgia Tech. It's what I graduated with. So I studied me. It was all about introspection. And one of my favorite things was thermodynamics. This is just the study of like heat transfer, how things, heat moves and flows. And one thing that I noticed is I would do all of this work, and at the end, like I would either get the answer like right or wrong. It was like very clear, very cut and dry. And like, have you ever been working on a test and then you wrote like -1,000, and then it turns out to be +1,000, and you're like, oh, I'm so close, but you're really, really far away actually. So in school land, school world, you have somebody to tell you that is right, that is wrong. Like, what about the real world? So this was kind of a question that I had, and with that in mind, I went into one of my first co-op jobs, actually designing and building refrigerators for General Electric. It was not this exact refrigerator. So just on a side note, this is a multi-billion-dollar corporation, and to design these refrigerators, they use the most sophisticated software that money can buy, which is spreadsheets. Everything is just spreadsheets upon spreadsheets. So okay, I'm like, all right, well, we got this thing. We're building refrigerators. We use spreadsheets. What if the spreadsheet is wrong? And that's kind of when I was talking to some other guys, and it sort of dawned on me. Testing. It's genius. We build this spreadsheet. We say, oh, this refrigerator is going to behave like this, and we can actually turn around and test it. You put it in a room with controlled temperature, you put thermocouples in it, and it will actually tell you if the refrigerator behaves like you predicted it would or not. So I actually think that compared to building and testing refrigerators, programmers are insanely lucky. Okay? We have generally known inputs, we have generally known outputs, and the really cool thing is that our product is a program, and to test it, we write programs. Like, that's the equivalent of building refrigerators and testing it with like mini refrigerators. So not everyone is so lucky. So in the 1960s, we made a plan to go to the moon. And this is kind of a really ambitious thing that we've decided to do as a nation. And if you don't know, outer space, it's a little bit inhospitable. It's a lifeless vacuum. Lifeless vacuum, and we're actually sending people there. So it's like, you don't want to get this wrong. I mean, you don't want to make a Monday off by one mistake. So you're going to do a lot of calculations, and how do you actually trust those calculations? And I mean, to me, this is kind of an untestable situation. So they actually kind of thought about it, and they were like, well, okay, what is a rocket? A rocket is built up of a bunch of components. It's like, well, what if one of those components fails? It's like, well, we should probably figure that out really quickly. So they actually broke up the rocket into all these little mini components and strapped them to test fixtures, which you might have heard of. It's not a folder in your Rails app. But they would actually segregate these and just test one by one. So you would actually just test the engine all by itself. But even with this, even if you test the engine and the cockpit and all these things, you still have to put it all together. And there was a reporter who was interviewing Alan Shepard, and it was like, okay, what were you thinking as you were like sitting on top of that rocket? And it's like, I was thinking this thing was made by the lowest bidder, is exactly what I was thinking. So at the end of the day, you actually, in order to see if it all works, you need to launch it, right? Like, that's how you know if your rocket works. So they did that. They actually launched rockets. And so this is kind of an integration test. Or if you saw the talk earlier, a safe test. Though it's not safe necessarily for all of those involved. So, okay, that's kind of a little bit of an aside. That's where I'm coming from. But I would like to talk a little bit more about software. So some more about me. I work at a company called Heroku. And at Heroku, I work on a Ruby task force. And on this task force, I am, in fact, a Ruby task force member. We also have Ruby task force meetings and Ruby task force managers. You get the point. So, okay, audience participation time. Name the year of these things I'm getting ready to show you. Not this current year. That would be like way too easy. Okay. Just shout it out if you... Okay, so this is 2007. Originally, Heroku was built very single purpose for the intention of making deploying Rails apps really just insanely easy. And since then, we've actually kind of expanded a little bit. Now we run a variety of languages. Like you can even use a variety of frameworks. Like you can just run arbitrary Ruby code. It's pretty great. And in order to do this, Heroku introduced the concept of a build pack. So if you're not familiar with this, it's a piece of code, and this is something that I manage along with Terrence Lee, who is speaking tomorrow. And you type in git push Heroku master, and it actually sends it to our system, and we have to figure out, okay, what type of a project is this? Is this Ruby? Is this Node, Python, Scala, or any number of other ones? And then it actually executes and runs your code. So what I focus on is the Ruby build pack. What actually it basically just runs bundle install, but it does so much more than that. Right now it's currently about 4,573 lines of bundle install, edge cases upon edge cases, just where we have different versions of Ruby, different versions of Rails, like all these weird cross compatibility issues, and it just all has to work, right? So as of January 2013, I would like to, well, not necessarily like to, I will tell you that it had exactly 0 tests. Like, not plus or minus. It's an open source project. This is a knowable thing. So before you freak out, okay, it was tested. It was just a little bit in manual. And with a giant asterisk that we did have platform tests, but platform tests are more like, is Heroku working? Is all of this working together? And I came onto the team with very little historical knowledge or wisdom, and I had no way of knowing, okay, if I'm going to build this thing and deploy it and push it out, is it hitting one of those edge cases of edge cases of edge cases? Which, if you're Heroku and you're handling hundreds of thousands of apps, that edge case of an edge case of an edge case can happen multiple times a day. And that's no good. So taking a couple of steps back, has anybody heard of an MVP? Does anybody know what this stands for? Okay, I don't think I heard anybody say minimum viable patch. Okay, so if you're not familiar, a minimum viable patch, and that's probably good, by the way, but a minimum viable patch is a change. It's not going to be the most maintainable or flexible. It's definitely, well, it might not be the most fast, but it's the easiest thing you can possibly do. It's like, oh, I've got a problem, and I want to fix that bug in my code in the quickest and easiest way that I can without impacting any of the rest of my system. So the problem with this is that when you deal with these patches, too many of these minimum viable patches, even if you have beautifully architected, amazing code, it starts kind of just creeping in, and your code becomes really difficult to maintain. You start to get duplication, all these other things Katrina was talking about. So does anybody have any guesses for what the possible cure for an MVP would be? Refactoring? Okay. Yes. And there's one other thing. Tests. Okay, so has anybody ever read the Working Effectively with Legacy Code? Okay, we got, good. So Ruby is destined to leave many legacies. Take that as you will. So one of the things that we talk about a lot in the book, or I didn't write it, Michael Feathers does, he talks about is black box testing. So we just take all of the inputs and we kind of shove it in our program, our software, and given a known output, we see did it work or did it not. Like the same inputs should give you the same outputs every single time, unless your black box is a randomizer, in which case it should be predict anyway. So in this scenario, we're actually ignoring how everything all works, and so that's how we're going to start approaching this problem. So previously, you were told that never, ever, ever, I think there were three steps if you're testing something that has multiple different network dependencies. And the first was don't ever use those network dependencies, and the second was don't ever use those network dependencies. Well, in our scenario, we don't have that option. So we actually have to have real apps, real deploys, and really exercising our system. To help that out a little bit, I wrote a framework for actually building and deploying Heroku apps called Hatchet, and it hacks tests. You can find it at github.com/Heroku Hatchet. And the very short, simple version of what it does is it's going to clone down a repository. It then creates a Heroku app, and it deploys that Heroku app. It's kind of the 1, 2, 3. In this scenario, our Git repo is the input, and our output is the deploy log. It's pretty reasonable. Has anybody ever used Heroku Run? Okay, yeah, great. What about Heroku Run Bash? Okay, slightly fewer hands. As soon as you get out of here, go run Heroku Run Bash. It is amazing. It just spins up a new dyno, and it puts you right in the shell, and you can do whatever you want. ls, cat, you can rmrf the whole file directory. It doesn't matter because you're in a dyno and it's isolated. Don't do that though, in case you're not in your dyno. Okay. Also, what about versions of Ruby? Anybody using 2.1.1? Raise your hand if you're using 2.1.1. Oh, sorry. If you're not using 2.1.1. Okay, great. I will have the video record that no one raised their hand. Everyone was using 2.1.1, which is fantastic. Also, are there any PHP users? Okay, this is totally, actually, really not a joke. Send me an email, richard@heroku.com. I've had something Heroku-y I would like you to try out. Hopefully you will be happy, and you can also find me and ask me about that later. So, okay, back to where I was going with this. I wrote a piece of software that actually lets you programmatically drive these types of REPL sessions, where Rails console will actually kind of put you into a scenario where normally you would type things out and you can expect a response. So Hatchet will actually allow you to drive these things. So you can run Rails console, put in hello plus world, and it will actually spin that up on a box on Heroku and run this command and relatively give you predictable output. And we need to be able to do this because even if the deploy output says, yes, we installed Ruby 2.0, if there was something wrong with that binary that we installed, we're not actually exercising it. So this is a way we can actually exercise that code run on those boxes. The library by itself is relatively simple, takes an input, spins up a session. You can then pass other things to it, and it will return those in a relatively deterministic way. So this part of it looks relatively simple, but it took me freaking forever. Let me see. And mainly, whenever you're trying to programmatically control a session like this, you have to deal with a lot of process deadlock. So, so that is again part of the output. So we have logs that we can take a look at, and we can actually interactively run things on the apps we just deployed, which is pretty useful. So going back, we have the input again. So in the previous example, I was using a Rails 3 app. And we have a GitHub repository called Sharpstone where we keep roughly right now about 47 different repositories of edge cases. And these can be like Ruby 2.0, Rails 4. Whatever, RC, all of these different kind of like a matrix of edge cases. Also, on a side note, has anybody ever written like thread.new? Great. It's a lot of fun. You should try it. I wrote a library just for fun. Like one weekend, I read Jesse Stormier's book. I think that's how you say his last name. I don't know. And I was like, oh, I'm totally going to write a library now. And I wrote it, and I call it Threaded. I have a Ruby gem name driven development where I think of a name, and then like I figure out what it's going to do. And it just so happened Threaded was available. So I wrote this interface where it's basically a promise interface, and you can just call like threaded.later, and it will just do that thing later. And you can actually kind of have multiple of them and chain them up, and they behave in a relatively reproducible way. So originally, the hatchet tests have to do this. They have to actually clone down the repositories. And originally, when I was doing it, they were doing it one by one, actually shelling out in order to do this. And it took about 45 seconds or so. Throwing my little toy library in there with a little bit of threads, and we brought that down to about 2 seconds. And it just so happens this was a really parallelizable case, but I'm here to tell you that like threading in Ruby is here. The future is now. Go out there. This isn't a talk on threading, though. So back to actually running and writing the tests. Once we clone that app, we bring it down, we copy it to a temporary directory, we create a new app through the API, and then we deploy. After we deploy, we do those assertions, kind of like we saw previously, where we're looking at the deploy output, or we're actually running those things. So all of that you've seen so far is the input and the output. And according to like the Michael Feathers book, like we're done. Like Blackbox testing, done, boom. So now we get into the like nitty gritty of the 3 rules we heard earlier. So what if, as you're running your tests, S3 goes down? Or what if Ruby gems goes down? Or the Heroku API glitches for a second? Or if your local network kind of hiccups? Then your tests are going to fail. And they're not going to fail because your code is wrong, and they're not going to fail repeatedly. And if you can't get your tests to fail repeatedly, then it's really, really frustrating. I've never seen GitHub being down ever, so that obviously wouldn't be a case. So when these happen, your tests fail, and then you're sad, and you're in this untestable kind of scenario, which when this happens, we run into these cases. It's fine. We need to find ways to simply retry those failure paths. So there's a 8-line gem I wrote called Retry, mostly because Retry was taken. And basically, all deploys are retried. Like if we deploy and there was a failure and you didn't mark it as saying like, oh, you probably like. We want to test failures too, right? Like I want to flag it and say, hey, this is supposed to fail, don't retry this. But by and large, most of the things I'm testing for are the positive happy path. So by default, we are going to retry deploys 3 times. On another side note, Bundler 1.5, is everybody upgraded? Upgrade, Bundler 1.5, I think 1.6 just came out, so upgrade to that. Bundler is now parallel. We're doing parallel installs with Bundler. The future is now. And a little feature I added to Bundler 1.5 is it actually also does automatic retries on gem installation. So if it can't reach Ruby gems, then it'll just retry. If it can't do a git operation, it'll retry. By default, I think it's up to 3 times, but you can configure that. So definitely upgrade today. You will not regret it. So in our case, deploys are, again, not a programmer by nature. I'm going to go with idempotent. Okay, all right. So you can still have other problems, like other problems dealing with the network that aren't in that deploy phase. So here's where we can have different network hiccups. Say maybe we're doing that Heroku run bash or Heroku run console, and we need to actually hit our network. In this scenario, we are using a library in RSpec that will just automatically rerun your test if it fails. It's like, oh, that test was supposed to pass. Well, it failed. We're gonna rerun it. So in this scenario, we're kind of going on the fool me once, shame on you. Fool me 6 times sequentially, and there's probably an error in my code somewhere. Yeah, that's a development tactic. It's legit. You don't know that saying? And what we're trying to do is combat non-determinism. Like inherently, we're working with a non-deterministic system. We are touching networks. They do go down. And in this case, we're using probability to approximate that determinism. We can't ever fully approach it, but I can say that if I'm getting a failure, I should at least look at it to determine whether or not it's a valid failure or not. And if everything works, even if it's only 1 time out of 6, I'm pretty sure that it's going to be capable of working again. So this also has the side benefit of as we're doing all of this testing, sort of speeding up the iteration cycle, speeding up how quickly that we can actually write and ship features. But the actual tests themselves can take a little bit of time. The very first version of this library that I wrote took about 5 minutes for every single test. I mean, it was like pulling stuff down. It was like creating new apps. It was doing all of this stuff. Since then, we've had about roughly 1,000 Travis CI runs, and we can do about 44 test cases in 12 minutes. So, I mean, here we are actually literally deploying over 44 apps in 12 minutes. So if your test suite takes like 2 hours to run, that might be a little bit too much. So some things that we did to kind of increase or increase the speed is we switched over to a parallel test runner. Again, luckily we have the capability of doing this just due to the nature of our work, where each app deploys to a different server, and most of the time is just spent sitting there waiting for Heroku to be like, oh, here's your standard out. Also, we had the nice benefit of the build pack got faster. The build pack actually got about 40% faster. The Ruby build pack got about 40% faster. And this is not an accident. These two things did not happen in isolation. It's not like we wrote tests and like, oh, hey, sometime later our test got faster. Being capable of iterating and being confident in the code that you're writing allowed a little bit more freedom and flexibility. Where we could actually go in and do some really major refactorings, whereas previously we were kind of like limited to that minimum viable patch. So we were just really aggressive with refactoring. And I mean, we went at it with the idea that we wanted a little bit more performance out of the platform. So those big architecture changes resulted in big changes in speed. And I'm not going to say that testing made it faster, but it definitely helped. At least it helped in my case. Also, tests tend to beget tests. And once we were able to write these integration style tests, these like untestable tests, then we could actually start pulling things out of that test suite. It wasn't just a like one and done, like, okay, oh, we've got this giant test that takes like 5 minutes to run. We'll just, oh, we got a failure. Okay, I guess I'll make a small change and tweak it. So we actually worked a little bit to pull really common things like, say, running rake tasks or detecting Ruby version and build those into modular components that we could then test those individual components. And those are much, much, much faster. So whereas it takes maybe 30, 45 seconds to deploy a Ruby app, it only takes 1.63 seconds to run this unit test, which is testing how we are integrating with rake. So, of course, faster tests means faster integration, faster turnaround time, and hopefully that also cycles around into meaning faster application, right? Like our build pack actually literally got faster, so therefore our test suite got faster, so we could iterate even faster. Are you seeing a trend here? All right. So in a little bit more relatable of a scenario, I also am working with a library called codetriage.com. Is anybody familiar with code triage? Okay, I got some hands. There's some contributors in the audience. The short version is that it allows you to receive one GitHub issue per day from your repository of choice. So say github.com/rails/rails. If you want to get involved, but you don't want like all of the issues, just one simple issue a day, you can comment on it. You can say, I don't think this is valid, or like, hey, I can probably fix this. Like, it's just, it's fun. So check it out. One thing about the codetriage.com is it also has an external network dependency. So it talks to github.com. As you can imagine, it's interfacing with all of those issues. And it's written in Rails. We can still test the whole thing all together. We can still drive it from a user interaction perspective. And what this is going to look like, what our Blackbox testing is going to look like, is actually clicking on buttons, observing page changes, and you're probably familiar, you probably worked with Capybara before, but I really like this style of testing. It's definitely a lot of work involved. And again, it doesn't do anything with the network. So we still have all that network stuff that we're dealing with. But in this scenario, GitHub's pretty static, or hopefully static. Or anyway, the API is, and we're going to hear from Ben relatively soon with API testing, so he might totally refute everything I'm going to say. But such is speaking. So for that, we can use something called WebMock. Or in our project, we're actually using another product that actually consumes WebMock, uses WebMock, called VCR. And VCR allows you to record real traffic and then turn around and play it back inside of your tests. It records these inside of something it calls a cassette, or just cassette.yaml. So in this scenario, we're actually exercising the website exactly as a user would see it, but we never actually have to go out and hit GitHub. I mean, if their API changes suddenly, then there's nothing we can necessarily do about that. We can't know about that. And as it was suggested previously, we do actually use an intermediate network interface. I wrote a gem called GitHubub, name-driven development. And this was, like right before OctoKit was released. So anyway, you can do this inside of your own Rails apps. Like, I highly encourage this. You can also do this inside of your libraries. I have recently been playing a lot with Puma. If you're not familiar, Puma is a web server. It's similar to Unicorn or Thin. By default, whenever you just start up Rails and you say Rails server, it gives you WebBrick. And you should not be running in production on WebBrick. Puma actually allows you to scale out by multiple workers, multiple different processes, and also multiple threads. Again, future, here, now, you get the point. So one thing that I've run into is just this constant question on Heroku of like, okay, all right, good, I'm running Puma, I'm running Unicorn. How many workers do I need? How do I actually, like, how many workers does my app need? It's no longer just a static answer. It's no longer just one. So I wrote this gem called Puma Autotune, and it actually optimizes the number of workers based on RAM. You tell it exactly how much RAM your system has, and it will increment that number of workers that you are running until you consume all the RAM on the box, kind of without going over. You don't want to go over, then you'll start swapping and things will be slow. But it's still kind of in the beta phase. I recommend checking it out. Give me some feedback, please. But okay, it's kind of a difficult thing to test. Like, there's a lot of logic involved in that. It's not just a like run this one simple calculation. We are actually now dealing with a relatively complex system, RAM, memory usage, and how these all interact. So again, in order to do this, we can actually really test drive it. In my test helper, wrote a little class that actually runs Puma. So it just spawns Puma into a different process, and then we log things. We send it to a log, and from there, we can use a little stub app. It doesn't do anything. Like, we just need it to take up memory, which thankfully Ruby is really good at. And then we just take a look at the logs, and we can from inside of Puma Autotune, we can log whatever we want to log, and then we can read back in those logs and assert that what happened, what we want to happen, what we thought would happen is happening. So we've got our input and we've got our output. If you've ever used a library called Unicorn Worker Killer, it's very similar in nature, totally untested. But there's not really any reason why it shouldn't be. Like, if you are doing something in code, like, there's probably a way that you can also turn around and actually do that thing you were doing via testing. And these are all running on Travis, so like it's possible. It's not super easy. It's going to take some time, and there will probably be a little bit of hair pulling involved, but it's like way better than not testing at all. So okay, that was kind of a lot in just one sitting. At the end of the day, like, nothing is untestable, which makes my talk title like total talk bait, like link bait but for talks. If you don't know where to start, if you don't have tests, if you're dealing with a system that is too monolithic, maybe you didn't even design it or build it, you weren't there, maybe it's not even something you're necessarily designing with yourself, start with integration tests. Once you have integration tests, they will tell you if you're going to have pain. You want to test the things that will tell you if you're going to have pain. When I was working for a company called Gowalla, we had user sign-up broken for 3 days. So Gowalla was a social network. I don't know if you know this, but apparently you need users in order to have a social network. And we didn't have it tested. So as soon as this happened, I went out there and, like, I mean, we had integration tests. We were just always mocking that part of it out to be like, oh yeah, here's your signed in user. So now we made sure that we did that. So if it's going to hurt you if it happens in real life, make sure you test it in your code. And of course, we can use your tests to refactor and write smaller, faster tests. I'm pretty sure if you counted the number of times tests has been said in this talk and like the entire conference so far, it would be like astounding. So Rubyists obviously care about their tests. And this one is very near and dear to my heart. I don't like getting woken up at like 3 in the morning, especially if it's because a number of people can't like deploy their Heroku app. So instead, we just test for those cases that will hurt. We get all of our edge cases that really matter. You want to avoid your minimum viable patch. Like, you really, really want to be maintainable and flexible, fastable. But just, yeah, at the end of the day, be tested. So my name is Schneeman. I've written some libraries like Sextant, Wicked, and I've got an amazing book that I've co-written with another gentleman from Heroku called Heroku Up and Running. I actually have a copy of it here. You may have guessed the flow of things by now, but best question gets a copy. Does anybody have any questions? Oh, well, actually, we can clap first, and then we can do the questions. Thank you.